Hey robotics, this is some up-close detail that I feel we may have missed in the first couple days with instruction. We talked about these wire cutters and the gauge system that's used to measure the size or diameter of the wire, and the fact that the number doesn't necessarily correspond directly to the size. In fact, the lower the number, like a 10 gauge wire, the larger the wire hole. The wire that we are going to be using for wrapping our motors is an 18 gauge copper wire. So if I open this up and find my 18 gauge opening, we can see that it mates up with little clearance. If I go to 20 gauge, it'll actually crimp down on it and it would hold it in place. This cutter on the bottom, or the bottom of the wire strippers, is made for cutting. And notice it says cutting copper only. And the reason for that is people that cut wire, like steel wire, end up damaging the jaws. And you can see that opening right there is not, that's from cutting a hard steel wire. So copper only. Okay. Something else we want to look at. This is copper wire, but it's a real dark copper color until you sand off the clear coat that keeps it insulated from contacting itself. So when we wind our armature, the wiring is going to be right next to each other, and we don't want that to transfer or conduct through from wire to wire down the end. We want it to go through the wire all the way up and through the wire all the way back down, which creates an electromagnetic field. In order to expose that wire on the end, you need to sand off the clear coat. So I just want to show you this process. Take a piece of emery cloth, that's what this is called when it's sandpaper that has a real flexible backing. And then you're going to pinch this in between here and pull. And you'll do this a number of times until you begin to expose the bare wire underneath there. And then if you just rotate like 30 degrees, clamp onto it again. We want to make sure we get rid of all of that clear coat material. You can see that I probably still have some on there that I should sand away if I was going to solder this end and get it exposed. So we're going to do that for both ends of our commutator. Both ends of our armature. That's this right here. We've got a little bit of excess. We'll trim this once we put our commutator half on the shaft, but you're probably going to need about this much, because we're going to wrap that around the commutator half and solder it. A little bit more on detail in regards to quality of wrapping your wires. We had instructed in the video to wind the wires starting at one side of the base and winding up this direction, and then making a double wrap down, then going over center, going up this direction and making a double wrap here, and leaving a tag end out on that end. So you want to make sure you leave a tag end at the start or beginning and at the end as well. This is done correctly. This one, not quite the level of detail, okay? Would this still function? Possibly, but could we do a better job with the detail of the windings? Most definitely. What would we do at this point? You could unwind this and rewind it and try and stay tighter together. Something like this. This is beautiful work here. Or you could possibly rewrap, but keep in mind this copper is of value. It's very expensive. It's $20 per pound, something like that. So it's not something that we just want to say, oh, I'll just try again. We want to do it well the first time around. Last thing I wanted to demonstrate in the details video is cutting copper pipe. So we saw this once in the instructional video. Some people did. You may not have seen this already, but Mr. Phillips' video explains how to use this tubing cutter in order to cut a 3/4 inch section of material off. let me line this up so you can see it. So this is threaded on the bottom, and it's going to bring this cutting wheel, actually it's going to bring this roller jaw up closer here, and I'm going to line up where I believe is 3/4 of an inch. And once I tighten this up or snug it up, I can rotate this or start to spin it. And as I rotate this, you'll see a line start to form on here. I'll need to clamp it tighter yet. And what I'm looking for here, this disc right up here is what's actually going to do the cutting. Okay, I just made about a half turn in again here, and now that disc is starting to settle in to a groove. See if I can get this to line up here. There we go. What's happened here is this is walked out here because it wasn't tight enough, possibly because the end was oblong. But I'm going to cut this section off here, and we'll do it one more time for demonstration's sake. You can see that it's actually parting that metal, and at some point here it'll break through that. Right there, it broke through, and I've got my piece that has come off, but it's probably a little wider than I would like. So we're going to try this one more time. I'm going to loosen this so that it opens up enough to get the cutter on there. I'm going to get the cutter to where I think 3/4 of an inch is. Of course, I could measure this. And then I will put some tension on this to start. And I'm going to say we want to rotate towards you with the jaws facing you, and that's going to keep the wheel to finding a singular track. Turning this up, adding about a full turn of tightness now. And another turn here. And one more turn to finish it off. Okay. And another piece of detail that Mr. Phillips talked about with the utility knife, but which I will demonstrate with an actual deburring tool, is to take off the burrs on the inside of this. And there really isn't too much for burrs or a ridge, but we can use this tool right here, go around this, and just peel off the inside so that it's smooth here. There's a pretty good burr or lip on this side. So I can keep working this. This copper is fairly soft in order to cut through. That's getting there. So the cutting lip on this deburring tool is right there. We just do want to be careful that we keep our fingers back, so if the tool were to slip, we're not going to catch ourselves. So we'd finish deburring this so that the inside edge here is smooth with the rest of the diameter of the pipe. And then the last part about the details, this is a tin snips, which is used normally for steel. A lot of times the lock is put on so the jaws can't open. So you squeeze the handles together a little bit, pull the lock back, and this will open up. Mr. Phillips was demonstrating how to cut this. So we want to put a parting cut in this, and we want that to cut vertically like this, straight through if we can, and get as far back into the jaws as you can. There's one cut. We're going to make a second cut, sorry, not quite at the center mark. So if we look at that, we don't want to be centered on this. This is one of our commutator halves here, and then we're going to trim off and try and match these up, make them the same. So on the bottom they're the same right now. On the top we have to take off about a 1/2 inch. So I can mark that, so I know specifically where I need to cut that. Okay. Okay, and I might have a little bit of finishing to do on these two halves just to soften up the edges and such, but they are going to mate onto my dowel and leave some gap or room in between.